Welcome back, Doc Walkers. It's one of your boys from the Doc Army, Gabe. And rather than talk about our Apex Legends Season 2 expectations and predictions, I'm going to be talking about something that's more of a pressing matter, and that's the AP Calculus AB exam. So the thing about how the AP Calculus exam is set up, you're going to need to get through as many questions as you can super quickly. Like, you're going to be spending at least max probably a minute a problem. So you're going to need to find quick ways of finding different solutions to many different kinds of problems. And one type of problem that occurs on the test every year is finding complex derivatives. Now, right now, you're learning about how to find simple derivatives, like using the power rule or using the product rule or quotient rule. Sometimes you can't just use those ways in a lot of situations. And there's going to be complex derivatives where you're going to need to know, like the chain rule, which you're going to learn to solve these different equations. So I'm just going to write that here. The chain rule is finding complex derivatives. So what is one type of derivative that would look hard on the test? So let's see what we got for our first example. So we have 4x squared. One way you're probably thinking of solving this problem is by squaring that inner function, which is the 4x. So if we did that, which is probably what you're thinking we're doing, we would do 4x times 4x. And that would simply be 16x squared. And then we would just use the power rule in this case. So we would put the 2 multiplied by 16, and that would be 32x as our solution. So that's just by using what we know from algebra and just a tiny bit of calculus. But if we're going to use the chain rule, how do we solve this? So for the chain rule, you need to find an inner function and an outer function. You would then find the derivative of those two values and multiply them together to get your solution. So since we solved the solution for this one already, we got 32x, we're going to try the chain rule and see if we get that answer. So for the inner function, I'm going to call it a u. So I'm going to say that u equals 4x. And then I'm going to need an equation dealing with u that will make it so it's just like this equation right here. So we go back here. So we already have our u value. So we need to do something will make it the 4x look just like this. So I'm going to say u squared. Now I need to find the derivative of the two and then multiply it together. So the derivative of 4x is just 4. And I would do that times the derivative of u. And if I did the power rule for g of u, I would just use right here. So the derivative of g of u would be 2u. So 4 times g, the derivative of g of u would be 4 times 2u. And that would be 8u. So what do? We only have a u value remaining. Well, we already know what u equals because we set that up originally. We said u equals 4x. So I'm going to do 8 times 4x, and that will be 32x, which is what we got earlier. So just like I said, the chain rule, you simply just have to multiply that inner function you create and the outer function you create. So let's try, after we erase all this, we're going to try looking at a similar example to this problem. And if you want to try to do the problem yourself, just pause the video before I start explaining it and work it out, and then start the video right back up. So let's look at our second problem. So this one's extremely similar to the first one. We have 3x plus 1 being squared. So I would need to first create my inner function. So I would say that u equals 3x plus 1. So that's going to be my inner function. And my outer function is going to be this value, which is u, being squared. So like the last one. So I'm going to say g of u equals u squared. I need to find the derivative of the two, then multiply them together. So the derivative of u in respect to x would just be 3. So I do 3 times the derivative of g of u. So the derivative of g of u, it's just going to be using the power rule, bringing the 2 in front of the u. So it would just be 2u. So it would be doing 3 times 2u, which is 6u. And we already have what our u value equals, which is right here. It'll just be 3x plus 1. So 6u is like saying 6 times 3x plus 1. And that would give us 18x plus 6. So you're going to be seeing many kinds of problems like this on the AP test, whether just like how we've been doing, dealing with stuff values just being squared, using your inner function and outer function. Well, there's going to be problems that aren't just squared, though. You're going to have raising to different exponents, such as being raised to the third power, being raised to the fifth power, or sometimes they can be just like this example. It could be finding the square root of something. Now, for this one, you don't really know how to start your 3. You don't really know what to have this 3x squared minus 4x plus 7 is. But I'm going to rewrite this equation so it looks like the other two that we did previously. So if you're finding the square root of an equation, it's like raising that equation to the 1/2 power. So I'm going to rewrite this equation as 3x is 3x minus 4x. So let's see. All right. So I'm going to do, in parentheses, 3x squared minus 4x plus 7 raised to the 1/2 power. Now, just like before, we're going to have an inner function and an outer function. So our inner function is going to be what's inside of these parentheses, which is 3x squared minus 4x plus 7. And this time, our outer function, which I will call g of u, is not going to be u to the squared, because this time it's being raised to the 1/2 power. So we're going to need it to be u to the 1/2. Now, we got to do what the chain rule says. Find the derivative of both of them, multiply them together, we're getting our answer. So let's find the derivative of u first. So if we do the power rule, we're going to have the 2 multiplied by the 3. So this is going to be 6x minus we use the power rule. So there's like a 1 here. Bring it here. That would just be 6x minus 4. And the derivative of a constant value, which in this case is 7, would just be 0. So we'll ignore that. So we have to do the 6x minus 4 times the derivative of g of u. So g prime of u, if we bring the 1/2 up here, we're going to have 1/2 u to the negative 1/2. And just like we learned from algebra, if we want to have a negative exponent to positive, we just bring it to the denominator. So g prime of u also equals 1 over 2 the square root of u. And since we already know our u value, when I rewrite it right here, I'm going to substitute my u value in. So our derivative of the square root of 3x squared minus 4x plus 7 is going to be 6x minus 4 times 1 over 2 our square root of 3x squared minus 4x plus 7. And when I multiply these, I can already say I can divide the 2 from this. So if I cross out this 2, I can just cross out the parentheses here, and it would be a 3x minus 2. And when I multiply them together, It's just simple algebra. It will be 3x minus 2 over the square root of 3x squared minus 4x plus 7. Now, these are the kind of problems you're actually going to see on the AP test more likely. These harder calibers where the solution's not going to look as nice as it usually does, but you're just going to have to get used to doing this multiple times in order to understand it and for its wide capabilities and uses that you'll learn eventually in the class. So these don't have to just be used with like simple equations with no like crazy different kinds of signs like saying the natural log or log of values. But in this case, let's try something you've learned to this point, and that's finding derivatives of trigonometric functions. So let's look at our next example. So this one is sine of 4x squared. So for this one, I'm going to have to need that inner function and outer function. So we already know by now what the derivative of sine of something is, or like sine of x. It would just be cosine of x. So that's what we're going to do right here, but instead of x's, we're going to be using a u value. So I already see the sine, there's a 4x on the inside right here. So that's what I'm going to make my u value, which is my inner function. So I'm going to say u equals 4x squared. And I'm going to make my outer function, the g of u, equal the sine of the u value. Now, just like the chain rule says, I need to find the derivative of these two values, this one, and I have to multiply them together. So if I find the derivative of u, that would be 8x times the derivative of g of u. So the derivative of g of u, so I need to know the derivative of sine of u, which is the same as sine of x, but that would just be the cosine of u. So I do 8x times the cosine of u. But since we already know what our u value is, which is 4x squared, we just put that into our final answer, and that will give us our correct solution. Now for what we've been using, most of the time we've just been using the chain rule once, but there's also going to be times when they try to throw in a difficult problem or two, you're going to need to use it more than once. If you feel like you're really grasping what we're doing right now, I want you to try and work this problem by yourself real quick and pause the video. But in case you want to see me walk through it, then just start it right, but you're still listening to me by now. So let's start by explaining this. Okay, so we have cosine squared of x to the third. So we need to figure out how to make this, what inner function we need to make this look simple. So for this one, we can't just use x to the third, because that would just have us have a cosine squared of u, and we can't just find the derivative of that. So I'm going to say that our u value equals cosine of x to the third. And then our outer function, g of u, will be u squared, because cosine of x to the third times itself will be cosine squared of x to the third. So now we need to find the derivative of these two values and multiply them together. So I'll start with the g of u. Now if we do what we've been doing, g prime of u is going to simply be 2u. So I'm going to do 2u times the derivative of cosine x to the third. Now we can't just use our trig identities in this case. We're going to need to use the chain rule again for the cosine of x to the third to find the derivative of that. So for that one, I'm going to split off into two equations again. The u being x to the third, and then another outer function, I'll call h of u, equals cosine of u. And if I found the derivative of these two values, I will multiply them together, and that'll give me my derivative. So I would do 3x squared times the derivative of cosine of u, which is negative sine of u, but we already know our u is x to the third. So we know the derivative of u, it's negative 3x squared times the sine of x to the third. So I'll write that into this one. Now we have these two values. We just multiply them together, and we'll get our final answer. So we have negative 6x squared u times the sine of x to the third. But now we already know our u value from our original part, and that's cosine of x to the third again. So I put that in, and that will give us our final answer, which is negative 6x squared sine of x to the third times the cosine of x to the third. Now just know, this is the kind of stuff you're going to be seeing, and as scary as it may look now, I hope I kind of gave you a good introduction to what the chain rule is. And if you're still feeling unconfident, try to rewatch this video and see if you catch something that kind of you didn't notice before, and that will maybe help you have a better reinforcement of this rule. If you want to try to see harder stuff, I recommend trying to use Khan Academy and other resources to find hard practice problems that'll kind of over prepare you for the AP exam. And as hard as that sounds, it's actually good to be over prepared than under prepared.